In this problem, they want us to graph y equals 1/2 times the absolute value of x. So notice that that 1/2 is in front and outside of the absolute value. So let's see what this looks like. So we're going to make a table as we usually do. So we're going to have x, we're going to have our process, we're going to have our y. That could have very easily been an f of x because f of x and y mean the same thing. And then we're going to have a column for our coordinates. Go ahead and draw in my columns. So what's going to be the center? Well, there's nothing happening on the inside of that absolute value around the x. So our center is going to be 0. So I'm going to put 0 right here for center. And then that means that this is going to be -1, -2, -3. Okay? And then here I have 1, 2, and then I'm going to squeeze 3 in down here at the bottom. Okay, so I'm going to move the book so that we can actually have a little bit more room to work. Okay, so what I'm going to do is I'm going to take 1/2 the absolute value of -3. Well, the absolute value of -3 is 3, so that gives me 3/2. It's a fraction. Not happy about that, but that's what it is. So now the next one I'm going to take is 1/2 absolute value of -2. Well, the absolute value of -2 is 2 times 1/2. That gives me 1. I like that number. Then I'm going to take 1/2 times the absolute value of -1. That's the same as the absolute value of -1 is the same as 1, so that gives me 1 times 1/2, which gives me 1/2. Then I have 1/2 times the absolute value of 0, which gives me 0. Then I have 1/2 times the absolute value of 1, which gives me 1/2. So if you notice, I'm just taking my values of x and I'm plugging it in for wherever I see an x in my function, and then I'm just cranking out the numbers and I'm getting my y. Then I have 1/2 absolute value of 2. Well, that equals 1 because the absolute value of 2 is 2. 2 times 1/2 is 1. And then I have 1/2 the absolute value of 3, which is the same as 3/2. So if you notice, our numbers kind of mirror each other. So I go down and back up. So this coordinate is -3, 3/2, -2, 1, -1, 1/2, 0, 0, 1, 1/2, 2, 1, 3, 3/2. Okay, so I'm going to take all those values and I'm going to go ahead and graph it. So I'm just going to kind of plan ahead a little bit. If I notice, I do not have any negative y values, do I? So I'm going to not have much in the way of negative y-axis. Okay, so let's go ahead and plot these points. So let's plot our integers. So I go -2, 1, 0, 0, 2, 1. Okay, so we can see that gives us a nice spread. So this point, let's look at this point, 3, 3.5. So 3, 3.5 is the same as 1.5, which would be right about there. Okay, and if I were to go out one more, I'm going to find that I'm going to get 4 and 2. So if you notice, this is like, remember we talked about slope on the right side? So I go up 1 over 2, up 1 over 2, up 1 over 2. I'm going to do the same thing on the other side, mirroring it. Up 1 over 2, up 1 over 2. Okay? So that means this is what my new function looks like. Okay. So remember I was saying up 1 over 2. That looks like slope, doesn't it? Up 1 over 2. Now I'm saying over 2 because remember absolute value goes both ways. So one side's a positive and the other side's a negative slope. But we're just going to look on this right side and then mirror our left side. Okay, so we have to compare that with our parent function. So remember our parent function is boring. Here was our parent function. So this is just something you're going to have to memorize. With our parent function, we had 0, 0, and then it went up 1 over 1, up 1 over 1, up 1 over 1. Up 1 over 1, up 1 over 1, up 1 over 1. Okay, so not a whole lot going on with the parents. So remember, because I'm comparing it to the parent, I'm going to go ahead and draw that in. So we can see, did it shift up or down? No, it did not do any shift because the vertex is the same. So the vertex is the same for both the parent and the new function. But what did we notice? This flattened out, right? It's like somebody was pushing down on the side of our V's, pushing down. So pushing down is called a compression. So what's happened is we've had a compression of 1/2. And we see that 1/2 right here. Compression of 1/2.